If you didn't write something nice up in the box up above, you could fill this in here, right? The logarithm of a number is the power of 10 that it's equivalent to. In other words, the logarithm of a number is the exponent necessary in order to express the number as a power of 10. Just for reference here, of course, if you have a to the b, this is the base. This is the exponent, and the whole thing together is called a power. All right, if you're wanting to use words properly. Now that you know that, let's do it in a different language here. Okay, this is what this is equivalent to. Teach you about logarithms, something new, and then say, now do it in another base other than the one you're familiar with, which is base 10, right? We use base 10 because, why do we use base 10? Why is our number system base 10? What do you think? Not sure? Why is it base 10? Why is it not something else? If you ever watched The Simpsons, their numbering system should be base 8, actually, if they really did truly evolve it themselves. That's it exactly, right? What did you just do? That's why, right? Because, I mean, it's nobody sat down and said, hey, let's make up a numbering system and make symbols that go up to, as soon as you get to, okay, I'm tired of symbols, now you're just going to put this and put another thing after it instead, right? And use that. It's because we have 10 fingers, right? And as soon as you get to, as soon as you run out of fingers, you need a way of doing it. So you get to there and you say, one whole set of hands and 0 extra fingers, right? And one whole set of hands and 1 extra finger. I mean, that's what it is, right? From thousands of years ago. And it's slowly evolved into all this clever ways of writing it and everything. But that's it. So now that you've learned that, we're going to think about logarithms with other bases as well, because we can extend the concept to any base. Okay, and it's not going to be as hard as counting in other bases. That's difficult. But you do have these two keys on the calculator. On almost any scientific calculator, it should have those two keys. Those two functions, now hopefully you have a sense of what they might do. You don't have this key, and you don't have this key. Those would be inverses of each other, right? This thing up here I just called the logarithm key, but really it should be called the log base 10 key. Because when you look at the logarithm key, it says nothing about it being base 10, but this one does. It shows you that the base is 10. Really, you could write it as log with a little tiny 10 down here to say that's what base it is, that's the number we're using as the base. This looks too long. Mathematicians don't like to write lots. So what they do is invent ways of writing things to be lazy. So they write log with a little tiny subscript 2 because they're lazy and maybe because they like to frustrate high school students. Because if you're not very good at keeping your handwriting organized like me, you might tend to, instead of writing log with the little tiny 2 down here, your 2 might be a little bit too big. And then it starts to look like something different, right? What does that look like other than it looks like a terrible looking 2? But other than that, that doesn't look like log base 2. What does that look like? Just log of 2, right? This would actually mean log base 10 of 2. If you, whoa, that's kind of funky. Now it looks really bad. Not quite sure why that happened, but we'll go back to this, right? So it's important that you write nicely, because sometimes you're going to be writing log base 2 of 2 to the 2 and stuff like that. So you got subscripts, you have superscripts. You have to be writing very carefully. What is that equal to, by the way? Anybody know? Take a guess. It's not. Actually, you'd have more of a chance of getting it right if you were a grade 1 kid. Because if you said, what's that equal to? They'd probably say, 2. It's equal to 2. But we're going to get there why it's 2 in a second. Okay? You don't have these keys because it's not very often that you need base 2 for stuff, unless you're a computer programmer. You certainly don't need base 3 or 5 or 7 or anything like that. Base 2 is binary. You use that in computer programming. Base 8, I understand there's uses for. maybe base 16, but so that's one reason you don't have it is you don't use it very often, except in Math 12. The other reason that you don't use it is because you can easily, we're going to find ways of getting it in with using these other keys, or actually the fancy calculator I will show you. I'm by no means am I trying to, I think I already told you this, but couple people in my calculus class last year said, hey, I hooked this up to the computer and updated the operating system or whatever, and then their calculator could do all this fancy stuff like make the numbers small here for exponents. It could do square roots where the number actually shows up right underneath, right? Whoops. And stuff like that. So if you do have one of these and you want to find out how to do that, you can ask me and I'll show you. But nonetheless, you don't have those keys. If you want to do this, first we need to understand what this means, right? If you understand how base 10 logarithms are related, you should understand how these are related. Now let's stick with numbers that are nice. Like 2 to the 5, what does that equal to? 32? So what has to be true? How can we write that with logarithms in terms of base 2 logarithms because the base is 2 here? How can we write that with base 2 logarithms? If I wanted to say log base 2 of something is equal to something. Remember that the log base 10 of something, let's see what it says up here. The logarithm, I should say the base 10 logarithm, right? Really, I mean the base 10 logarithm of a number is the power of 10 that it needs, that the number is equivalent to. If I was to now go back and say the base 2 logarithm of a number is the power of 2 that the number is equivalent to, right? So if you say, what's the logarithm base 2 of, I'll write it down below so there's more room. What's the logarithm base 2 of 32? Logarithm base 2 of 32 is, what power of 2 is that, did you say? It's 5, right? Logarithm base 2 of 32 is 5. You can write a few other ones here. Logarithm base 2 of 16 is 4 because it's the 4th power of 2. And so on, right? Logarithm base 2 of 8 would be 3. I should have organized this before I started writing it so it's clear. But what are some other ones we know here? Logarithm base 2 of 4. Logarithm base 2 of 2. Log base 2 of 2, what's that? It's a 1 because it's 2 to the 1, right? The thing I said before was log base 2 of 2 to the 2. That's basically log base 2 of 4, right? What's 0 equal to here? Log base 2 of 2 to the 0, right? Or in other words, 1, right? Logarithm of 1 is always 0. Because 1 you can always write as whatever the base you're using, it's that to the 0 power. If I ask you what log of base 2 of 2 to the 16,384, what's that? Log base 2 of 2 to the 16,384? 16,384, right? What did we start out saying? You don't have these keys on a calculator, but what are these two keys? How do they relate to each other? If I had to write that on a calculator and I had this, log base 2 of 2 to the power of that number, right? Those two functions. Like if I had those keys on my calculator, I'd say 16,384. I'd push the 2 to the power of key, and then I'd push the log base 2 key, right, of that. What do these two functions do? Log base 2 and 2 to the power of. They're inverses. They cancel each other out. All right? This is a lot to digest at first here. There's a whole bunch of questions after this that are going to help you understand these things. And I want you to work on. Try filling out these statements. I gave you one where I did the easy one for you because we've already done it and it's easy numbers. I gave you one here where you can think about what's the log base 3 of 81, what's the log base 7 of 7. Maybe this is pushing you a little bit too far, too fast. But you can try. I think at this point it's better if I help you individually with this, or in pairs, or whatever. Work with the person next to you to try and rewrite some of these in the other form using logarithms. Write some of those, filling in some of the boxes there. Or make up some of your own examples. If you don't want to make up boxes, if you don't want to fill in the boxes, you can just say log base 5 of 25 is, what would that be? What power of 5 is 25? What exponent does it need? Here's you thinking. Actually, I got to draw you first, and then you can be thinking. Here's you. You're not very happy. You're not very awake either, so here's you thinking. You're dreaming about logarithms. You're thinking log base 5 of 25. 5 to the power of what is what I'm looking for? Right? So you're looking for this. This is the number you're looking for. What power of that base? It's 2, right? You can make up your own here if you want. You don't need to fill in my examples here, right? So if somebody says, what's the log of base 3 of 81, like what I had over there? You're thinking, what power of 3 is that number? What power of 3 is that? Do you know your powers of 3? It's 4, right? That's what a logarithm is. So just try working on that page. Sometimes it's easier just to make your own stuff up here than to fill in what I've done, right? All I've done is just make some questions up for you to practice this. You can feel free to make up your own on the side here. You can write something with logarithms and then write it in exponential form. Write something with exponents and then write it the other way. Like if you find that easier, make up your own stuff instead of doing those, okay?